Hi, today we are going to discuss about Nobel Prize in Physics 2022. It has been awarded to three scientists for the work exploring quantum weirdness. They are Alain Aspect, John F. Clauser, and Anton Selinger. They were recognized for their experiments in an area that has broad implications on how to transfer data securely using quantum computing. And they were recognized for conducting experiments concerning quantum entanglement. And what is a quantum entanglement? It is a phenomenon that occurs when two particles behave as one, even when separated. And quantum entanglement has been a hot topic of research for past few years. And three physicists who work on this quantum entanglement showed that nature is even weirder than what Einstein once thought to be. And they will split the price about 7.46 crore rupees, Indian rupees. And what I can talk about their work is that all the works are independent works. And they explored the foundation of quantum mechanics, the rules that governs the subatomic world. In experiments conducted in the last 50 years, uh, this quantum mechanics has confirmed that there are certain effects which Albert Einstein uh, said that these effects are not valid because it contradicts the relativity, and he said that these type of quantum entanglement are just spooky actions at distance. He called like that, this quantum entanglement. Anyway, one of the basic principle that you have to uh, talk about while discussing this Nobel Prize is measuring one of the widely separated pairs of particle could instantly change the result of measuring the other particle, even if it was light years away. This is the topic we have to discuss while discussing Nobel Prize in Physics 2022. So this is what is called, what the physicists are calling the strange effect called quantum entanglement, and it is now a basis of a growing field of quantum information. So, um, when the awards were announced, one of the members in Nobel Committee, her name was Eva, noted that this quantum information science has broad applications in the areas like cryptography and quantum computing. So this new field of science, which we call as quantum information science, is a vibrant and rapidly developing field, and its prediction have opened doors to another world. Actually, it has also shaken the very foundation of how we interpret measurements. And I have just seen a video by Dr. Daniel Kabat, a professor who was working on MIT, now in Lehman College in Newark. He explains that we are used to thinking that the information about an object, say like a glass is full of half full, so somehow we are not at all interested in water, but also we are interested in the glass also. It is in a way to say that somehow uh, the glass and water are actually entangled objects, and without one, other cannot be explained. Like instead of, he says that entanglement means object only exists in relation with the other object, and moreover these relationships are encoded in wave function that that actually stands out of tangible physical universe, a very word used by Dr. Daniel Kapath. And quantum mechanics actually arose in the earlier decades of 20th century, and this time period was called the second scientific revolution, and as scientists trying to understand the inner lives of atoms, and its centerpiece as the centerpiece of that quantum mechanics, heart of that quantum mechanics is actually Heisenberg's contribution, that is Heisenberg's uncertainty principle, which came in 1927, which says that a certain type of knowledge of particle position and velocity, for example, are incompatible. The more precisely one property is measured, the blurrier and more uncertain the other becomes. And this was actually being put to test or was put to discussion by a thought experiment by Albert Einstein in 1935. He wrote a paper along with Boris Podolsky and Nathan Rosen, and this paper was popularly called as EPR paper. And what he tried, Einstein tried, was to demolish quantum mechanics, or was to planning to say that the quantum mechanics is an incomplete theory, and these quantum rules that measuring a particle in one place could instantly affect the measurement of other particle, even if it was miles apart. This was actually a wrong notion. And there was a this actually it was a thought experiment. So there was this philosophical arguments about the relativity started, and actually till 1964, well, where with John Stuart Bell, people will be always familiar about Bell's inequality. He was a theoretical physicist in CERN, who was skeptical about this quantum mechanics claims. So he actually thought, why can't we try an experiment and test whether Einstein is right or quantum mechanics is right. And in these lines, we have to talk about Dr. Clauser. Uh, he he had a knack for doing electronic experiments, and also he had some thoughts about quantum theory. So he was the first to propose an experiment which could be actually be done based on Bell's inequality. And he actually says that he happened to go through this Bell's paper while he was a graduate student in Columbia University. And he thought that, okay, there is something he could do about it. And in 1972, in this picture, you can see he using a duct tape and spare parts in the basement of the campus of University of California, Berkeley. Dr. Closian and his graduate student, and his student's name is Friedman, and he recently died in 2012. And they decided to perform Bell's experiment to measure quantum entanglement. And in a series of experiments, what he did is that he fired thousands of light particles or photons in opposite directions, and then they tried to measure a property called polarization, which could have actually two values, up and down. And the results of each detectors was always seemingly to be very random up and downs. But when the two detectors were compared to each other, the ups and downs matched in a way that neither classical physics nor Einstein's law could explain that. So, but we can say that there is something weird effort in the universe, and entanglement is actually a real fact, and it seems to be a real thing. And these things are very nicely put forward by uh, a book by David Kaiser on how hippies saved the physics. He said that at those times when Clauser was working on this, most physicists were not interested in even arguing about the meaning of quantum mechanics. They were always interested in building atom bombs or transistors. So actually, Clauser was always pushed back by scientists, and they didn't even consider this as even doing science. So, who is Kaiser? This photo is of David Kaiser. He's a professor of physics and history of science at MIT. His videos are available on YouTube, and he says that they had to have a lot of stick to to publish their result. They had to go through a lot of rigorous review process to publish their result. So that is what Kaiser told just last Tuesday. And here is what Clauser says about. Uh, I hoped we could overthrow quantum mechanics. So that was his thought, and everyone else thought, oh, John Clauser, you are totally nuts. So this was actually said in an interview which was seen. while seeing the videos of Nobel Prize lectures. In this interview with AIP, that is American Institute of Physics, Dr. Closer admitted that he himself had expected quantum mechanics to be wrong and Einstein to be right. He tried to do an experiment with this mentality, but that's how a nice scientist is. He tests these things, and he has come up with a truthful result. He says that uh, he had no choice, and this quantum entanglement was real, and it contradicts what he believed or what his guts used to believe. And his notion was to overthrow quantum mechanics, but after the experiments, he had to accept that. And the catch in Dr. Claus's discovery and quantum mechanical description of this spooky action was correlated only to show up measurements where the physics compared the results after the fact. So we have to say that entanglement seemed real, and it could be used to communicate information faster than speed of light. And in this context, Dr. Aspect, the other person who got Nobel Prize, there are three. So the second one in line whom I want to discuss is Dr. Aspect, who is a professor at University of Paris. And in 1970, while he was on the way of getting his doctorate, he was spending 3 years performing teaching quantum mechanics for uh, students in national service requirement, and he had spare time in learning about quantum mechanics. And last day with the interview with the Nobel Committee, he said that he returned ready to return to France, ready to tackle the proposed problem of Bell's inequality. And uh, in this context, we have to come up with the Selinger's contribution. So Dr. Aspect's results of entanglement on the map as a real phenomena that physics and engineering could use. The quantum prediction held true, and but he also proposed that there could be many loopholes in Bell's experiments that Dr. Closer has identified and which need to be closed before quantum physics could declare victory over Einstein. For example, the polarization direction in Dr. Aspect's experiments has been changed regularly, and thus theoretical predictions, fashions that could be sensed by photons or detectors. And it was then the Anton Selinger comes into picture. He was a professor in University of Vienna, and he's also called the ringmaster of quantum trickery. And he picked up the baton, and in 1998 he added even more randomness to the Bell's experiment using random number generators to change the direction of polarization measurement while the entangled particles were in flight. And once again, what happened is that the quantum mechanics was the winner. They beat the Einstein by like overwhelming margin. And whatever aspect was saying that there could be some locality loopholes, still that was completely closed, and there were still many possible criticism, but like there was a theory called free will theory, and people also argued that experimenters and experiments were actually influenced by these free will theories also. But then in recent times, Dr. Selingers and his collaborators has done some cosmic bell experiments. That is, they were studying the fluctuations in distant objects like quasars, which are billions of light years from here, and as random number generators to set detectors directions. Now they have found that scientists have found that there are entangled particles, and entanglement is one of the main features of quantum mechanics, and it has wide variety of applications in cryptography, quantum computing, and moreover in future maybe a quantum internet, which could be $1 million, or we can say $1 billion market we will find for quantum internet. And what of now we can say that there is a one success which we can share is that the cryptology, that is the message sent in entangled pairs, and which can send cryptographic keys in a secure manner. We can say that it's the most secure business right now. Any eavesdropping, like someone is trying to see into this, will destroy the entanglement and alerting the receiver that something has happened. And in 2017, Dr. Selinger used his technique with entangled photon beam from Chinese satellite Miscus to have an encrypted 75-minute video conversation with his student, a Chinese student from Chinese Academy of Science. His name is Jai Wei Pan. And while receiving the Nobel Prize on Tuesday, Selinger acknowledged that there are more than 100 of young people who had worked on him for the past years, and this achievement is actually an encouragement to young people. And he said that he also had an advice for the youth, and also he said that my advice will be, do what you find interesting and don't care too much about possible applications. And that's a very good advice which we can keep. However, with quantum mechanics actually could not be understood by our ape brain. That is a fact. As the pioneer Niels Bohr once says that anyone who think quantum mechanics was outrageous hadn't understood what was being said. To conclude this discussion, I would like to share a quote by Richard Feynman. He says that if you think you understand quantum mechanics, you don't understand quantum mechanics. And the same in these same lines, Dr. Closer in his interview with the AIP says that I confess even to this day that I still don't understand quantum mechanics, and I'm not even sure I really know how to use it all that well. And a lot of this has to do with the fact that I still don't understand it. Anyway, a beautiful message to be given to the youth. So I hope you like the presentation. Thank you all. We'll come up with a discussion soon in our department. It's an open day discussion on Nobel Prize in Physics 2022. Thank you for patiently watching. Thank you.